Hi everyone, thanks for checking out this companion video to the main written post of HyperMu's 7th devlog entry. The link to that is in this video's description. As detailed there, HyperMu now has a closed-loop simulation mode, which lays the groundwork for much higher fidelity tire models and full lap simulations in the future. This video is a short demonstration to accompany the full devlog, showing how the user can switch between open-loop and closed-loop modes by using a single flag and providing input data of the correct format. We've set up this demonstration as a PyTest so it could be integrated into HyperMu's CI flow. It's a very simple test which only requires both simulations, one open loop and one closed loop, to complete without any exceptions. First, notice that each simulation runs on the same vehicle spec. Syntactically, the major difference is the use of the CL mode flag in the closed loop simulation. Open loop mode is the default. And also the input source is changed. The open loop mode uses inputs from a 6-axis IMU gathered from an autocross event last year, while the closed loop mode uses driving inputs like throttle, steering, and brake positions. We don't have real world driver inputs right now, so we'll use synthetic inputs instead, as this is enough to show the operation of closed loop mode. Specifically, this force function is a constant 15% throttle position request, so we only expect to see forward acceleration. We'll start the PyTest, and the open loop simulation will run first. And what we see is HyperMu display the standard results page, which we've seen many times in previous devlogs. So that's familiar. And by closing this, we allow the closed loop simulation to run. And what we see is a constant linear acceleration reacting to the constant throttle request. The speed increases linearly. The suspension reacts accordingly, squatting on the rear axle, as you can see from the spring displacement plots. And there's also some longitudinal load transfer, which could be seen from the tire vertical load plots. Also, see how the net tire load generally increases as well. This is a result of downforce taking effect at increasing speeds. The vehicle speed in closed loop mode is an integrated value that comes from the RK4 solver. It's not a given value from telemetry. So seeing the vehicle speed increase in response to a torque request is proof that we are indeed moving the vehicle model in a closed loop simulation by throttle request. Of course, there are multiple variables closing the loop, so to speak, but speed is just the easiest to demonstrate. This is all a very primitive example with simplified engine and gearbox models. It basically behaves like an EV powertrain right now. So a full analysis of longitudinal motion with correct internal combustion engine models and gearbox models will surely be a future devlog topic. Thank you so much for watching.